Now we're going to look at another situation we might run into when we're solving equations. So our directions here say solve each equation on the interval from 0 to 2 pi. So the first one we have here is cosine squared of x plus 2 cosine of x minus 3 equals 0. Now we want to think about this like we would the equation x squared plus 2x minus 3 equals 0. And if we were to solve that, we'd have many different ways of doing it. We could use quadratic formula or completing the square. But another way we could do it is factoring. So we could factor this as x plus 3, x minus 1 equals 0. And we can factor our original problem here in a very similar way, just where we have x, put in cosine of x. So we'd have cosine of x plus 3 times cosine of x minus 1 equals 0. Now, just like we would over here in our quadratic situation, we'd set x plus 3 equal to 0 and x minus 1 equals 0 and get x equals negative 3 and x equals 1. So we're going to set cosine of x plus 3 equal to 0 and cosine of x minus 1 equal to 0. So we'll get cosine of x equals negative 3 and cosine of x equals 1. And now one time around the circle we want to solve these. Now this first piece is pretty easy. So if we look at cosine of x equaling negative 3, well that never happens because we know the biggest cosine it can get is 1 and the smallest it can get is negative 1. So that part never happens. Well, if we look cosine of x equals 1, we would look at our unit circle. Look one time around, we want the x value where it's equal to 1, so that would just be at 0. Okay, so the only solution we get here is that x equals 0. So let's go ahead and look at another one. So here, this one's already factored for us. And we're going to follow a very similar path. So here, we've got tangent of x minus 1 times cosine of x plus 1 equals 0. So we're going to set tangent of x minus 1 equal to 0 and cosine of x plus 1 equal to 0. So we'd say, okay, we want where tangent of x equals 1 and we want where cosine of x equals negative 1. So let's look at the unit circle and let's just work on the tangent one. Well, tangent is equal to 1 where the y and the x are the same. And the two places where that happens is at pi over 4 and 5 pi over 4. So our two solutions for this part would be pi over 4 and 5 pi over 4. And cosine of x equals negative 1. Well, here we want the x coordinate to be negative 1. That happens at pi. Okay, so we get three solutions here. Pi over 4, pi, and 5 pi over 4. Okay, we have one more we're going to look at here. So here we have sine squared of x minus 1 equals 0. And we want to think about this one kind of like we did the first one. So if we had something like, we want to think about how we would solve x squared minus 1 equals 0. And if we had that, we'd say, oh, well, x squared minus 1 is a difference of squares. It factors as x minus 1, x plus 1 equals 0. And then we would set each of those pieces equal to 0. So here we can factor this as sine of x minus 1 times sine of x plus 1 equals 0. Then we're going to set each of these equal to 0. So sine of x minus 1 equals 0 and sine of x plus 1 equals 0. So we need where sine of x equals 1 and sine of x equals negative 1. So we want all the places on the unit circle where the y is 1 or negative 1. And I know the screen's kind of cutting this off, but it's 1 at pi over 2 and it's negative 1 at 3 pi over 2. So our two solutions are pi over 2 and 3 pi over 2. Okay, so everything you learned about factoring and then setting those factors equal to 0 with polynomials or for quadratic functions also works if we have a trig equation.